Hello and welcome back to our next science lesson. We are continuing to look at materials and their properties and how the use of this can help our understanding of why certain materials are used for certain things. We're going to continue to look at thermal insulators. We looked at conductors yesterday. We're just going to continue our understanding into insulators. So just like yesterday, we still need to know what a conductor and insulator is. We need to think about predictions using existing knowledge, and we need to investigate which material is effective thermal insulators. So first off, conductor and insulator. The easiest way to think about this is conductor allows you to pass through, whereas an insulator will stop things passing through, whether this is heat or electricity. So if on my head, we're thinking whether my head is a conductor or an insulator. On one side, I have heat. If my head is a conductor, the heat would pass through one side and you would feel it on the other side. If it was an insulator, it would stop it. And the same with conductors. So, what you're thinking about is whether or not something stops the flow of heat or electricity, insulator, or lets the flow continue, conductor. Making predictions using existing knowledge is massively important within science. Again, we're thinking about this being the working scientifically skill that we're thinking about and really driving home. The reason why predictions are massively important is that what it actually is the reason we're doing the test. Yes, you've got a name, you've got a question that you're trying to answer, but the prediction is the reason you're doing it. You think this one thing is going to happen. You have to prove whether your ideas are correct or whether they're wrong. And that's where the prediction comes into. They're called a hypothesis. So you either have a hypothesis which is correct, and that's your idea, what you believe is going to happen, your prediction, or what's called a null hypothesis, or the opposite of your prediction. A null hypothesis is my prediction was wrong, basically. It's the opposite. So it's massively important, especially as you go further on in science and you think in all of the branches of science, your predictions are the reason why you are testing it. You're testing it to see whether or not you're right in your assumption, and you can then use that knowledge to your advantage. And then we're going to investigate which materials are effective thermal insulators, and that's what we're going to talk through now. So, just a recap from yesterday, your task was to think about what was to test the insulation properties or the conductive or insulative properties of different containers. So we picked 4 different containers, and there would be whatever containers that you currently had. And then you carefully, very carefully, making sure not to hurt yourself, put water into each of them. And your job was just to see which one remained the hottest over a course of time. And we said roughly 10 minutes. You come back and you check to see which one is the hottest. And we talked about the different ways you could do this. You could just feel the outside edge and feel which one was the hottest. You could touch water if you're careful, see which one's the hottest 10 minutes. None of them should be still boiling, so you should be fine. Or you think about if you're trying to do this scientifically and you had a thermometer, you could put a thermometer in each one and you could look at what their input is. If we were really going to go into detail with this and we were really looking at it, you would put the same amount of hot water into each container. The containers would be the same size. And rather than just measuring the temperature right at the end after 10 minutes, you would measure it in intervals leading up to it. And that would also tell you how quick the loss of heat happened. So you'd have even more information. So say, for example, at the end of 10 minutes, you came back and all of them were cold. You'd have no information as to which one was better than the other. Whereas if you had measured the temperature at intervals across that 10 minutes, say, for example, every 30 seconds or every minute, you'd have an idea of what the drop in temperature was, and you'd probably find that the drop in temperatures were at different rates. And therefore, you could see that the slowest one, the one that took the longest time to cool down, would be your better insulator, whereas the one that dropped off quickly is losing heat the most and is the worst insulator. So, well done. But we need to think about this. Is there any other way we could test, or any other things that we could test to make that even better? What we're doing is thinking about how we could take the investigation we've already done and do the next step, the further investigation, which continues to deepen our understanding of what an insulator is and what materials might be insulators. What could we do in order to do that? Think about it. Pause for a second. What else could we test, or how else could we test something in order to look at the properties of different materials? So let's think about this. If you are cold, it means the body's heat is escaping. So on a cold day, or on any given day, you're inside, it's nice and warm, your body's nice and warm, you feel nice and warm, you walk outside, and as you walk outside, the outside temperature is cooler, so the heat from your body is released to warm up the air around you. You get colder because there's less in it, less heat inside you. In order to keep that heat in, we need an insulator. We wrap ourselves up in something, normally a jacket or layers. And by doing that, by putting an insulator on, we keep the heat in. And one of the places, obviously, that we need to keep, we put a hat on. Classic example. And there's this thing that people say that the most heat you lose is through your head. Well, yes, but think on a regular basis. What's the only part of your body that isn't covered with clothes normally? Which is why you lose the majority of the heat through your head, because it is the thing that's open to the air. Unless you're wearing a hat, or if you wanted to cover your entire face, then you would obviously lose less, and probably through your hands, which would also be uncovered unless you're wearing gloves. So just the act of covering our bodies, whether it be with material or not, does work as a part of an insulator. So we might use man-made materials like jackets, furs, or natural materials like furs and leathers. It is also important to note that just the layering of lots of thin layers also makes a good insulator. And the reason for this is that in between each layer, you've got a gap of air. Okay. So what has to happen is you heat up the first layer gets hot, and the air gap has to get hot. Then the next layer, then the next layer, then the next layer, the next layer, and in between each one, you're having to heat that part of air. Also needs to cool down before it can affect the next layer, and this just means that there's more things that have to cool down in order to reach you, in order for you to lose your body temperature, and it just helps in that regard. And actually, you can see this, and this is used in lots of ways. We wrap hot water tanks so that the water that's heated once inside of it stays warm for longer. And this saves energy, because you have to think about it. Every time you heat that water up, you have to use energy to heat it up. And that energy for us costs money, obviously. But it means that it's warmer for longer and therefore loses more heat. So we wrap it in insulation. Even our windows, double glazed windows, means you got two bits of glass with an air gap in between. So when you're losing heat, you have to lose heat from the outside pane, then the air in between, and then the inside pane. So actually a lot less heat is lost, and this again saves energy because you don't have to keep heating your rooms in order to keep them cool. Okay, we've also got very simple designs such as draft excluders. So what they're doing is getting rid of that part which there is no insulation. So think about under your door, there's a gap that leads to the next room, or a gap that leads outside. And by putting a draft excluder, you're not letting that air travel freely between two places. And therefore, you have that stopgap. The air can't pass through, therefore the heat is kept in one place rather than escaping to another. Closing doors is just another good way. It's a bit like, you think about having your door open, all of the air in your room is very quickly going to transfer into another room with all the heat involved. But if you close the door, it has to work to get there by going through gaps. If you put a draft excluder, then it's going to save even more. So, in your room, you have it nice, cozy, and warm in your room when you're going to sleep, but you leave your door open, and all that hot air over the course of the night goes out into your hallway. Your hallway becomes warm, which then links into your living room, and by the end of the night, your room is nice and cold. Well, maybe if you closed your door and put the draft excluder on, even when you wake up in the morning, your room would still be nice and toasty. Okay, so how could we make our containers better thermal insulators? How can we make them even better than they are already? Well, when we're doing this, once again, it's a heat test. So you're going to have to use hot water. So really, really be careful. Make sure an adult is there to support you in this. And make sure you are careful in everything you do. So, your task. You choose one of the containers that you have already got. So, preferably one that you've got more of. So, at least 4 would be good. So, for example, in this case, I could choose 4 glasses as long as they're the same, or 4 mugs, because that's nice and easy to have a set of those. And this just means that it's slightly fairer because we're using the same base material. Then what you're going to do is you're going to use different soft materials to wrap around the container. So you could take a sock and wrap it around one of your containers. You could take some foil and wrap that round. You can take some paper and wrap it round. But what you're trying to do is use different materials to wrap around the mug or whatever your container is in order to try and keep more heat in, or see which of the different materials is better at keeping more heat in. Then you're carefully going to pour roughly half the container's worth of hot water into it. And then you're going to predict which jacket, much like we'd wear, will keep the water warmest for longest, very much like we did before. Which one of those jackets is going to help our container be a better insulator? Because what we're then testing are those additional materials, wool if it's a woolen sock, foil, paper, bubble wrap. If you happen to have some, you could use that and see which of those is the better insulator. And just like the last time, you're going to wait about 10 minutes probably, and then go back and feel the temperature of those containers and which one is still the hottest and which one is the coolest. If you do have a thermometer, brilliant, use it. But if you don't worry, just do what you can and feel the temperature on the outside edge. If you're going to do feeling the temperature, make sure you feel the temperature of one and then feel the temperature of another and see which one's hottest and compare them that way. If you do have a thermometer, maybe you could try setting it up so you do it at intervals and see whether there is a different drop off and it gets cooler at different rates. That might be a nice extension to your science, and see whether or not you can plot that on a graph and see the different rates at which they change. Then you're going to rank the insulators from hottest to worst to the coolest. So your best insulator will be, the water will still be hot, and your worst insulator, the one that is the coolest and coldest water that's in there. And then you're going to create a nice table of results that shows us, if you have done the interval ones, you could change your table of results and show a graph as well in order to show that drop off. The best graph that you could probably use would be a line graph in this case if you're going to do one, because that shows change over time and each of your readings are connected to the previous one, because the temperature change doesn't happen at fits and starts, it does happen on a gradual trajectory. thank you. I hope you enjoy this idea of testing ourselves and being able to do some science at home, and actually you coming to the realization of what the different materials are and the properties are. Good luck. I'm looking forward to seeing your results, and I'll see you in the next video. Goodbye.